Form 7 Mathematics, Pure Mathematics 4 Differentiation. Objectives. After this presentation, student will be able to do the implicit differentiation functions, parametric differentiation functions, differentiating exponential functions, and they will be able to do the examination style questions. First, implicit differentiations. So, differentiate the function of y square plus x cube equal 5 with respect to x. Now here we can see that this equation is implicit equation because y is not subject. Y square plus x cube equal 5. That is the equation. So when you differentiate this function, first you have to differentiate y square, the subject of x, and x cube with respect to x, and 5 also with respect to x. So we know that we can differentiate x cube with respect to x, then the answer is 3x square. When you differentiate 5 is a constant, so answer is 0. But we can't differentiate y square with respect to x. So what we can do? So we can differentiate y with respect to y, then you can change the subject y to x by multiplying dy over dx. So we know that when you differentiate y square, the answer is 2y. Then y you have to change to x by multiplying dy over dx. So when you differentiate earlier function, the answer should be 2y times dy over dx plus 3x square equals 0. So when you subject dy over dx, the answer is minus 3x square divided by 2y. So here only the difference thing is, what you have to do when you differentiate y with respect to x, first you have to differentiate with respect to y, and you have to change it to dy over dx by multiplying dy over dx. Okay, let's see how to differentiate x cube minus 2y square plus 7y minus 5x equal 8 with respect to x. Okay, x cube easily you can differentiate. When you differentiate x cube, the answer is 3x square. When you differentiate minus 2y square, first you have to differentiate with respect to y, so answer is 4y. Then you have to multiply it by dy over dx also, and the same thing we have to do for 7y also. When you differentiate 7y, the answer is 7. Then you have to change the subject. That means you have to multiply it by dy over dx. So when you differentiate minus 5x, answer is minus 5. Equal, when you differentiate 8, the answer is 0. So here you can subject dy over dx. When you subject dy over dx, the answer is 5 minus 3x square divided by 7 minus 4y. So here you can see, when you find dy over dx, you can see the x terms and y terms both. Then normally when we differentiate earlier, it came as only function of x, but here x terms and y terms both are there. Okay, let's see how to differentiate this function x square times y equal sin x plus 3y with respect to x. So you can see here x square and y is a multiples of two functions. So then you have to use UV method, and after that you have to differentiate sin x, and after that you have to differentiate 3y also. So when you differentiate x square times y, first I'm going to keep x square, differentiate y with respect to x, then I'm going to keep y and differentiate x square with respect to x. When you differentiate sin x, the answer is cos x. When you differentiate 3y, the answer is y 3. Then you have to change it to dy over dx. That means you have to multiply it by dy over dx. So when you differentiate y, the answer is 1. Then multiply it by dy over dx. So then x square times dy over dx, and after that we are going to keep y and differentiate x square. When you differentiate x square, the answer is 2x, then 2x times y, 2xy. So the final answer should be x square times dy over dx plus 2xy equal cos x plus 3 times dy over dx. So after that you need to subject dy over dx here. When you subject dy over dx, all the dy over dx coefficient you can take to one side and send other things to other side, then take dy over dx out, then subject dy over dx. When you subject dy over dx, that is cos x minus 2xy divided by x square minus 3. So here also you can see x coefficients and y coefficient both are there in the dy over dx function. Okay, find the equation of the tangent to the curve x square plus y square minus xy equals 7. So the first thing is you have to find dy over dx at the point 2 comma minus 1. So what you have to do, you have to differentiate this function first. Okay, when you differentiate 2x square, the answer is 2x. When you differentiate y square with respect to x, the answer is 2y, and you should multiply it by dy over dx minus, then you can see xy means that is the product of two functions. First I am going to keep x, then differentiate y, answer is 1, then multiply it by dy over dx, so minus x times dy over dx. Then I am going to keep y and differentiate x. When you differentiate x, answer is 1. So then the final answer should be minus y equal 0, because when you differentiate 7, the answer is 0. Then after that you can keep dy over dx things in one side and send other terms to other side. Take dy over dx out, then divide, so you can subject dy over dx. Dy over dx is equal y minus 2x divided by 2y minus x. So then we need to find the gradient of the function at the point 2 comma minus 1. That means x equal 2 and y equal minus 1. So dy over dx you need to find when x equal 2 and y equal minus 1. So you can substitute the value of x and y to the earlier equation. Then you can find the value of gradient, that is 5 over 4. So then we know that the gradient of the curve is 5 over 4 at the point 2 comma minus 1. So the gradient is there, a point that satisfies the equation also there. So easily you can find the equation of the line. So substitute in the coordinate of 2 comma minus 1 and the gradient 5/4. So finally you can get the answer 4y minus 5x plus 14 equals 0. So the equation of the tangent at the point 2 comma minus 1 is 4y minus 5x plus 14 equals 0. Okay, let's see this example. Find the equation of the normal to the curve 2x square minus y plus 3 whole square equal 1 at the point 5 comma 4. The first thing is you have to find dy over dx in terms of x and y. Then after that you can substitute the value of 5 and 4. Then you can find the gradient of tangent. Then after that you can find the gradient of normal. Then you can find the equation of the normal. So that is the procedure. So first I'm going to differentiate this function with respect to x. When you differentiate 2x square, that is very easy, 4x. So when you differentiate y plus 3 whole square as a power, you can differentiate then 2 times y plus 3. And the other thing is you have to change the subject to dy over dx. So you should multiply by dy over dx equal, when you differentiate 1, the answer is 0. So equal to 0. Here also you can subject dy over dx. When you subject dy over dx, the answer is 2x divided by y plus 3. So here the points are 5 and 4. That means when x equal 5 and y equal 4, you need to find the value of dy over dx. So the value of dy over dx is 10 over 7. That means the gradient of the tangent is 10 over 7. Then gradient of normal should be minus 7 over 10. So then you can substitute the coordinate to the equation, and a point is there 5 comma 4. So you can substitute the coordinates and the gradients, then easily you can find the equation of the normal. So then we are going to move to parametric differentiation. Parametric differentiation. So as an example, a parametric equation is there, x equal to 2t plus 5 and y equal 3t square. This is the parametric equation. So then we need to find dy over dx. X is there as a function of t and y also there as a function of t. We need to find dy over dx as a function of t or as a function of x and y. So let's see how to find dy over dx. The first thing is you can find dx over dt easily. Here the answer is 2. Then dy over dt also you can find. The answer is 60. Then we know that dy over dx should be equal dy over dt multiplied by dt over dx. So then you can substitute the values. Dx over dt means 2. That means dt over dx means 1 over 2. And dy over dt is 60. So when you substitute, the answer is 3t. So dy over dx in terms of t we can write as 3t. So in generally dy over dx should be equal dy over dt divided by dx over dt. So what you have to do, first you have to find dy over dt, then you have to find dx over dt, then divide dy over dt by dx over dt. Then you can get the gradient dy over dx as a function of t. here find dy over dx in terms of t. The parametric equation is given x equal cos 2t and y equal sin t. So I'm going to find dx over dt here. When you differentiate cos t, the answer is minus sin t. So when you differentiate cos 2t, the answer is minus sin 2t, and you should multiply by 2 also. Then the final answer should be minus 2 times sin 2t. So when you differentiate sin t, the answer is cos t. So then easily you can find the value of dy over dx. Dy over dx is equal to dy over dt divided by dx over dt. So I'm going to substitute dy over dt as cos t and dx over dt as minus 2 sin 2t. So then you can write dy over dx as a function of sin 2t and cos t. So then after that you can simplify further this function. You know that sin 2t is equal to sin t cos t. So cos t to cos t cancel. So when you multiply by minus 2, the answer is 1 over minus 1 over sin 4t. Or else you can write as minus 1 over 4 cosec t. So minus 1 over 4 cosec t is the gradient dy over dx. As a function of t, you can write as minus 1 over 4 cosec t. A curve is defined by the parametric equations x equal 3t plus 2 whole square and y equal 2t cube plus 9. So here also the same thing we can do here. First find dx over dt. 3t plus 2 whole square you can differentiate as a power. So 2 times 3t plus 2 to the power 1, and the differentiation function of inside one is 3. You should multiply that one by 3 also. Then the final answer should be 6 times 3t plus 2. Then dy over dt you can find easily. So when you differentiate 2t cube plus 9, the answer is 6t square. So dy over dx is equal dy over dt divided by dx over dt. So I'm going to divide those two functions. 6 to 6 you can cancel easily. So the final answer is t square divided by 3t plus 2. So dy over dx you can write as a function of t square divided by 3t plus 2. So then they have given the gradient as minus 1. So the gradient of the curve is minus 1. So I'm going to equal the gradient function to minus 1. Then you can form a quadratic equation of t. So find the solution of that t equal minus 1 and t equal minus 2. So when t equal minus 1 and when t equal minus 2, the gradient of the curve is minus 1. So when t equal minus 1, we can find the x coordinate, x equal 1, y coordinate, y equals 7. When t equal minus 2, x coordinate 16, y coordinate minus 7. So the gradient of the curve is minus 1 at 1, 7 and 16, minus 7. So differentiating exponential functions. Suppose we want to differentiate the general exponential function of the form y equal a to the power x. So first I am going to take log function, ln function, natural log function for both side of y and ax. So then we can take x as a power. You can take x to the in front of the log using the log rules. So then ln y is equal x times ln a. So now differentiate with respect to x this given equation. So we know that when you differentiate ln y with respect to y, the answer is 1 over y. Then you should multiply that by dy over dx also. And when you differentiate x ln a with respect to x, we know that ln a is a constant. So when you differentiate x, the answer is 1. So final answer should be ln a. So here you can form an equation that 1 over y times dy over dx equal ln a. So then after that you can multiply y to other side. So then can subject dy over dx here. When you subject dy over dx, the answer is y times ln a. So then y means a to the power x. So when you differentiate y a to the power x, the answer should be a to the power x ln a. For an example, when you differentiate 3 to the power x, the answer is 3 to the power x ln 3. When you differentiate 8 to the power x, the answer is 8 to the power x ln 8. 1 over 6 to the power x, the answer is 1 over 6 to the power x ln 1 over 6. Let's move to examination style corrections. This diagram represents a parametric equation x equal to t square and y equal t square plus 2t. The first part, find the gradient of the curve at the point P where t equal 1. Then find the equation of the normal at point P. C part, the normal to the curve at P, cut the curve again at point Q. Find the coordinate of the Q. So first thing is you need to find the gradient of this curve. So when you find the gradient, first thing is you have to find dx over dt, that's equal to 40. Then dy over dt, 2t plus 2. To find dy over dx, you need to divide dy over dt by dx over dt. So I'm going to divide 2t plus 2 by 40. After that you can simplify that. When you simplify 4t plus 1 divided by 2t. After that you need to substitute the value of t as 1. When you substitute, dy over dx is equal to 1. So the gradient of the curve when t equal 1 is equal to 1. So B part, we need to find the gradient of the normal first. So we know that the gradient of the tangent is 1, then gradient of normal should be minus 1. Also when t equal 1, x equal 2, you can substitute for the x equation. When t equal 1, y equal 3. So now you know the gradient of the curve minus 1, and you know the points 2, 3. So then you can easily find the equation of the normal. So the gradient is minus 1 and the 2 points are 2 and 3. So easily you can find the equation of the normal, that is y minus 3 equal gradient times or else minus 1 times x minus 2. So when you simplify, the answer is y plus x minus 5 equals 0. C part, so I'm going to substitute x equal to t square and y equal t square plus 2t to the equation of normal. Why? Because we know that the normal meet the curve again, so the equation of the normal and equation of the curve should be satisfied. Therefore, I'm going to substitute equation of the curve to the normal. So then when you substitute t square plus 2t plus 2t square minus 5 equals 0. Then after that you can simplify that equation, that is 3t square plus 2t minus 5 equals 0. So this is a quadratic equation of t. So you can find the solution of equation when you find t equal 1 and t equal minus 5 over 3 is coming. So we know that already t equal 1 is the point P, so we need to find the coordinate of the other point. So then definitely you have to use t equal minus 5 over 3. So when t equal minus 5 over 3, you can find the coordinate of x. So you can use the equation of x equal to t square. That means x equal 2 times minus 5 over 3 whole square. The answer is 5 over 9. Then like same, you can find the coordinate of y also by substituting the value of t to the equation of y. So then the y coordinates minus 5 over 9. So the coordinate of q should be 5 over 9 comma minus 5 over 9. Hope you all got something from my presentation. So thank you very much.